Concept 3, factoring ax squared plus bx plus c when c is negative. Alright, so when c is negative, we're actually going to be factoring it really in much the same way, except when we are looking to split our middle term into two different terms. Okay, so we can start our factoring by grouping. Alright, now before we did our two numbers, and I've been using y and z. So y times z is equal to our a times our c. So 4 times negative 5 or negative 20. Okay, and that is still the same. But now, because this is negative, and that tells me that my one of my terms inside is going to be negative while the other is positive. Now I'm going to be looking for, instead of y plus z, I'm looking for y minus z equals, in this case, 8. Okay? And this can be easier and it can be harder. For me, sometimes this makes it a lot harder, the fact that I'm having to figure out two numbers whose difference is equal to 8. But if you think about it in terms of, okay, I've got two numbers, and I need them to be 8 apart from each other. All right, that will often, I think, help. Okay, they need to be 8 apart from each other. Well, yes, the absolute value of the terms needs to be 8 apart from each other. Okay, so if I'm looking for two factors of 20 that are 8 away from each other, well, 2 and 10 are pretty much the only ones you're going to have. Okay, I can list them out. I've got 1 and 20. Okay, I've got 2 and 10, and I've got 4 and 5. Okay, 2 and 10 are 8 apart. Those are the ones that must be my factors. And because this is a positive 8, I know it must be a negative 2. Okay, it's going to be basically 10 minus 2. All right, so I can set my terms up. I've still got my 4x squared, and I've still got my minus 5. Okay, but now it gets a little harder to figure out which term goes where. Okay, we get a little bit of help because we know that this term is negative, right? Our second term of our second binomial is negative. And if that's the case, then our second term in our first binomial also has to be negative. Okay, so if I've got a negative factor, that's where I'm going to put it. All right, so I'm going to make sure that my second term here is negative, so my second term here is going to be negative. And then I'll have my 10x there. Okay, greatest common factor, 2x. So 2x divided by 4x squared is going to be 2x. 2x divided by negative 2x, negative 1. Greatest common factor here is 5. So 10x divided by 5 is 2x. Negative 5 divided by 5 is negative 1. I've got the same binomial, so I can put them together as 2x plus 5 times 2x minus 1. Okay? Good. All right. And just to reiterate, this is our change, right? Instead of y plus z, when we have that negative 5, that negative last term, we need to have y minus z. Okay, we need to figure out the difference of those two numbers. All right. So now let's do one more example. So 7 times negative 10 is negative 70. And I've got negative 3. Okay, I don't have to worry about this negative right now. I know that my two terms are going to be 3 away from each other. And in this case, that helps me out a lot because I know that 7 and 10 are factors, and I know 7 and 10 are 3 away from each other. Okay, so 7 and 10 are going to be my factors. All right, and it's going to be a negative 10 because this is a negative term, right? So I've got my 7x squared, and I've got my minus 10. I'm drawing my binomials. Okay, so figuring out which goes where, I want to have a negative in this binomial, so this is going to be a negative 10x, and this is going to be a positive 7x. Okay, the greatest common factor here is just x, because 7 and 10 don't share any factors. X times 7x is 7x squared, and x times negative 10 is negative 10x. Okay. Now these two actually, and you can look down here to get a hint on what we're going to do, these don't share any factors. Okay. Their greatest common factor is 1. All right, that's the only factor they share. So that's what I'm pulling out, and I'm left with 7x minus 10. Okay. It is the same binomial, so one of my binomials is going to be x plus 1, and the other one is my 7x minus 10. Okay.